Hello, my lovelies. So this is one of the last full lessons I'll be doing. Right now, you are also getting 1316 content in your classes with Miss Reyna's. So pay attention to all of it because that's going to show up on the final. So this is 6B. Hopefully you saw 5A yesterday because there's some of that on test 4. And then there's going to be some of 6A and some of 6B. You should be seeing 6A tomorrow. And it's dealing with the central values, central tendencies. This, on the other hand, is dealing with variation. So what we're going to look at here is how widely data is spread apart. And data can be really clustered or really, really wide apart. And depending on what the data is supposed to measure, that could be good or bad. Like, that's very much a subjective thing. What we're going to focus on is how to calculate those, and then a little bit about what do those mean for a problem. So our first one is we have Big Bank. So Big Bank has 3 lines with 3 tellers, and people pick one of the 3 lines when they go to queue up, and those are their average wait times in minutes. Best Bank has 1 line, also has 3 tellers, but people form 1 line, and then when they get to the front, they go to whichever the next teller available is. So their wait times are closer together. There's less variation. And then here we have a histogram with those same numbers. So we're going to do something else with the numbers in a bit. So I just wanted to kind of compare and contrast the two. Now it turns out the numbers are specially picked here. So the average is the same and the middle value, which you can see here, is also the same. So on average, people wait about the same amount of time. But Big Bank has more variation, which means they're going to have more grumpy customers. Whoever had to wait, especially 11 minutes, got grumpy. I've had that happen. And it was at a Best Bank line, and I was still grumpy, but it was a long line. So, interesting statistic. All right. Now, the next one we're looking at is range. So the range of a data set is the difference between its highest and lowest data values. So this is the absolute spread of the data. The absolute highest you get, take off the absolute lowest, that is as wide as the data is, period. So seems like, well, that should be a good measure of variation. Like, how wide is it? Well, let's take a look at example 1. So we have 2 sets of quiz scores for 9 students. Which set has the greater range? Would you also say that this set has the greater variation? Now I know gut check is no, because the answer is always no to those kind of questions. But let's figure out why. So quiz 1, I've got a single 1 and then a whole bunch of 10s. So that range is 10 minus 1, which is 9. And then the range on the second one is going to be 10 minus 2, which is 8. So according to the range statistic, the first set of quiz scores has a wider range than the second set. But look at quiz number 1. A 1 and then 10, 10, 10, 10, 10, 10, 10. So when you see the measures of central tendency, 6A, one of the things you guys should talk about is outliers. 1 here is an outlier. Everybody else got a 10 except for that one person. Maybe they just missed lecture and only had time to write their name. So it has a wider range, but the variation in it is almost non-existent. There's 1 outlier and a bunch of 10s. So really, it's not that varied if you drop the outlier out. Whereas Quiz 2 has an even spread across one of each of those different scores. So the data exists all the way across the range, not just at the ends. All right, now what we're going to talk about is the 5-number summary. So down here, it's the 5-number summary for a data set consists of the following 5 numbers: the lowest value, the lower quartile, the median, the upper quartile, the highest value. All right, so the lowest value and the highest value are the 2 things we were just using to find the range. Those are exactly what you think they are. The 3 in the middle are what the definitions here are about. So let's start in the middle. So the middle quartile, or second quartile as it's sometimes called, is the median of the entire data set. So median is not the same as mean. Mean is the meanest calculation, which means add everything up and divide by the total number. Median is the middle, and then mode is the most frequent. So this is what value is literally the middle value. Then the lower quartile divides the lowest fourth of a data set from the upper 3/4. It is the median of the data values in the lower half of a data. Exclude the middle value in the data set if the number of data points is odd. So a lot of the sets that we're going to look at are going to be odd. So we'll identify that as the median and kind of like put a mark in that, and then look at all the numbers that are smaller, figure out where the middle is, then look at all the values that are bigger, figure out where the middle is. And that's going to be our 5-number summary. So, and then we can use that to also draw a thing called a box plot or a box and whiskers graph. All right, so let's go ahead and figure out those things for the big bank data and the best bank data. The nice thing is our lists are already arranged, so that's the hard part. And I'm not saying that jokingly, like that's the most frustrating part about ALEKS is trying to order a list of like 20 values. It's annoying. Okay. You know what? Let's do some typing. Typing works better here. So for big bank, the lowest is right there at 4.1. And then we have the lower quartile. We'll figure that out in a second. The median, and then the upper quartile. And then the highest, which we can see is 11.0. All right, so the median, like literally you're just going to count the numbers. We don't really care what they are as long as they're in order lowest to highest. Whichever one is in the middle is the median. So there's 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5. There is our middle number. And then because best bank numbers are all lined up, so they have the same number, so the same position will be the median there. So they both share 7.2 as the median value. Here, let me go ahead and our lowest changes to 6.6 and our highest is only 7.8. All right, so now that we have figured out the median, now we're going to look at all the numbers on the left and figure out the median of just that. So this is an odd number of values. It's 11. So when we take the median out and don't count it, there's 5 on the left and 5 on the right. If it was an even number, the median itself would not actually be a value, it would be the average. And then that average line splits the data in half. But luckily here, 1, 2, 3, 4, 5. So number 3, there's our lower quartile. So it is 5.6 for big bank, but it's 6.7 for best bank. And likewise, our upper quartile is going to do the same thing, 5 values. That is value number 3. So we have 8.5 and 7.7. So if you look at those summaries there, so they go from lowest to highest, they're supposed to, but this one spans from 4.1 all the way to 11.0. This one only goes from 6.6 to 7.8. So this is a very wide span versus a very narrow span. So big bank has more variation, which is what we were talking about before. Now, once you have the 5 number summary, you can use that to draw a box and whiskers, a box plot. So we draw a number line that spans all the values in the data set. So here our lowest value is 4.1. So I want a number line that includes spaces for tenths, even if I don't have the tick marks, like I want enough space to kind of figure where it would go. And all the way up to 11 is my highest. So I need to see that sweep of numbers. But I don't need anything between like 0 and 4. You don't have to start on 0 for these. So if you're looking at like SAT scores, those numbers are huge in comparison to 0. So these are not graphs in the traditional sense, although it is going to look like we're using a Cartesian plane, but really it's just so we have the grid line so our drawing isn't so ugly. Okay. So we draw a number line that spans all the values in the data set. Enclose the values from the lower to the upper quartile in a box. The thickness of the box has no meaning. So you can make it a little bit thick or really thick, doesn't matter. Really, it's just a matter of however big you happen to draw it. Then mark where the median is and put a little vertical line. So you're going to have your low value and your high value. And then you're going to have, let me grab a different color, your lower quartile and your upper quartile. And there is the box. And then wherever the median happens to fall, and it isn't always perfectly between the lower quartile and the upper quartile. But this gives us a visual look at, so where's the bulk of the data between the lower quartile and the upper quartile, usually. And then how far does it span out is our little mark. So if you think of the box and then the little extension things can look kind of like whiskers. That's why it's sometimes called that. Yep, see, add whiskers, horizontal lines with short vertical segments at their ends extending to the lowest and highest values. I happened to start with that because it made the explanation easier. So here we have the actual box plots for big bank and best bank. And you can see here, here's big bank 4.1 all the way up to 11.0 versus our tiny 6.6 to 7.8. So the nice thing about box and whisker box plots is as long as they're plotted correctly on the numbers at the bottom, they're comparable. So I can see here their median is the same. The variability at big bank is much larger than the variability at best bank, or the variation, yeah, that V word. So Alex does have you guys graphing these. It's going to just throw a box plot up there, and basically each of the 5 points you can drag around to where you want them to go. So I'd say go ahead, low value, high value, get that out of the way. And then you can wiggle around the other 3 till they're at the correct spots. All right. Sorry, I had more room and then I decided to do a thing, so. Okay. So here we have 2 sets. And they're saying compare the variation in the 2 data sets with 5 number summaries and box plots. Okay, so I do think, yes, they are at least arranged lowest to highest. Thank you. All right, so let's start it off. Excellent. Should have paused the video, sorry. All right. Okay, so these are 20 numbers because they tell us that here. And very often they'll tell you, especially if it's more than like 9 or 10. And it's also just like standard practice just to tell you. So set number 1, our low value is 9.92. And it goes all the way up to 10.38. Now over here, set 2, 9.89, but it ranges all the way up to 12.00. All right. So now the median, because there are 20 values, there's going to be 10 in the lower side and 10 in the higher side. So in order to define the median, like there's no middle number like there was before when we had 11 values, there was 5 on one side, 5 on the other, and number 11 was in the middle. This, there is no middle value. So what you do is you average whatever those 2 values on either side of the middle would be. Sometimes they're the same number, in which case the average is just the same number. But here they're a little bit apart. So we have 10.13 and 10.14. And if we add and divide by 2, it'll be halfway between those guys, which would be 10.135. All right, now, same song, a little bit uglier verse. I have 10.98 versus 11.05. So that has a 2.5, so a 700th difference between them. Half of that would be 3500ths. Yeah, 0.035. So that would give us 11.015. Yes. But because I don't trust my mental math at the moment, go figure, it's after midnight. All right, let's see what it crunches up to. $22.03 divided by 2, 11.015. Cool. Not totally crazy. I mean, I am, but not about this number. All right, so now the lower quartile and upper quartile, we need to figure those out. So we've got 10 values on top, 10 values on the bottom. So on top, 1, 2, 3, 4, 5, and that's 6. So those are our lower quartile for set 1. So 10.065. And then the 2 just beneath it are going to be for the upper quartile. So that is going to be 10.195 You can think of it like it's obviously going to start with 10 point because they both start with that. So 180 versus 210, what's halfway between those two numbers? And then you could like do 10, so 190 and 200, 195. So there's my decimal. And a quick lesson in crazy mental math. So 10.3, no, I'm tired. Oh, no, 3.5. I typed 3.8 for some reason. Because that's what the answer is. And then our upper quartile, let me go ahead and mark those just so we are talking about the same numbers. So 11.55 and 11.76. So add them up and divide by 2, 11.655. All right, so we look at these and just the lowest versus the high value, and it's really the high values here. Set 2 has higher values. Its median is higher. Lower quartile and upper quartile are higher. Whereas set number 1 is going to be real tight together. Okay, I don't have the nice fancy paper to make this look like a pretty box plot, but just looking at the numbers, one of the things you can do, and it's kind of silly, but you kind of tilt your head so that you have the lowest value to the highest value, because that's how we usually plot it. Lowest on the left, highest on the right. All right, let's try it out when I actually have some fancy graph paper. See? Actually, I'll pause it and then pick it up. Sorry.